in-house or outsourcing. Once the capacity requirements are determined, the organization must decide whether to produce the good or service by itself or use outsourcing policy. Outsourcing is mean you have to obtain the good or the service from external provider, or sometimes you have to hire another person to produce for you. And the next one is show you just like the factor that we have to concern before you use in-house or outsourcing policy. The first one, you have to know available capacity in your organization. The next one is expert type. Another one is quality consideration. The next one, the nature of the demand, the cost, and the risk for outsource. The next one is show you just like the developing capacity alternative. There are many things that can be done to enhance on the capacity management. The first one, you have to make the design flexibility. Another one, you have to take the state of the life cycle. Like it means you have to focus on the life cycle. Another one, you have to focus on the big picture approach when you want to change the capacity, and then you have to prepare to deal with the capacity chunks and attempt to get the smooth capacity requirement and identify optimum operating level, and then you have to choose the policy or strategy if expansion is involved. And the next one, we go to bottleneck operation. When you see in this picture, right, for bottleneck operation, this is the same like the previous picture. For bottleneck operation, it means operation in the sequence of operation whose capacity is lower than another operation, right? When you see on the left hand side, the machine 1, machine 2, machine 3, and machine 4 have all the capacity is 10 units per hour, right? When you go to the next step or the next sequential operation, at this operation they can handle just only 30 units per hour. It means at this workstation they have the bottleneck operation, right? When you see the input is total is equal to 40 units per hour, but output they can handle just only 30 units per hour, right? It means on this system have the bottleneck operation. And the next one, we go to optimum operating level. For optimum operating level, when you see on this slide, right, every production unit always have an optimum rate of the output. At optimum rate, it means you can get the minimized total cost, right? When you see on the curve, on the y-axis, is about the average cost per unit, and x is refer to the rate of the output, right? When you see when the curve is at the bottom one or the bottom curve, right? At the bottom of the curve, right, you can see at this point is optimum point that you can get the minimum average cost per unit. And this concept can apply to economy of scale and this economy of scale. Just the economy of scale is mean if the output rate is less than optimum level, when you increase output rate, the result is mean they will decrease average cost per unit. And another one is about this economy of scale. For the this economy of scale, it means if the output rate is more than optimum point or optimum level, when you increase the output rate or you produce more, the result is mean the average cost per unit is going to be getting higher or getting increased. And the next one, we go to the evaluation alternative. There are many alternatives that we can use to evaluate the The first one, just economic. Another one, cost volume analysis, financial analysis, decision theory, the betting line analysis, simulation, and non-economic, it's just like the public opinion. But for this class, we just only focus on cost volume analysis. For the cost, before you go to the calculation part, we go to this part first about the facility size and optimum operating level. For this one, when you see for this graph, we can divide into the small pan, medium pan, and the large pan, right? On the y-axis, it refers to average cost per unit, and the y-axis and the x-axis is what the output rate. When you see on this one, the large pan have more capacity than the medium pans and small pans, right? That's why the large pan can produce at the high output rate. When you produce at the high volume or the high output rate, means average cost per unit is going to be getting lower. And then when you see the medium pan or small pan have the less capacity than the large pan, right? That's why the small pan or medium pans always have the higher average cost per unit when you compare to the large pan. That's why the large pan or the large factory always have the competitive advantage when you compare to the medium pans or small pan side, because on the large factory always have the large capacity or the more capacity or the more budget that you can produce more output than the medium size or small size factory. And the next one we go to the calculation part. For this part we go to just like the cost volume profit analysis, or sometimes we can call cost volume analysis. In this one it's just the calculation that we focus on operation management. For this one, this technique, we focus on the relationship between the cost, revenues, and volume of the output. The first thing that you have noticed is the fixed cost, or FC, right? It tends to remain constant regardless of output volume. And the next one, the variable cost. For the variable cost or the VC is vary directly with the volume of the output, and another or the VC is equal to quantity multiplied by the variable cost per unit. And the next one have to see just like the total cost. For the total cost is equal to fixed cost plus the variable cost, right? And total revenue or the TR equal to revenue or retail price per unit multiplied by Q. And the break-even point, when you want to calculate the break-even point, is mean the total cost and total revenue are equal. When total cost and total revenue are equal, you can get the break-even price. You can see from the equation, right? For the profit equal to total revenue minus the total cost, right? Total revenue equal to R multiplied by Q minus total cost is equal to fixed cost plus V multiplied by Q right here, right? When total revenue and total cost are equal, it means profit it becomes zero, and then you can calculate the break-even point, right? Break-even point on the Q, break-even point equal to fixed cost divided by R minus V. For this one, it shows you just like the cost volume relationship. When you see on the first picture, right? On the fixed cost is always constant, and the total variable cost is represented by the red line, right? And the next one, the total cost equal to fixed cost plus the variable cost that you can see on the back dash right here. And the next one, total revenue, right? Total revenue is R multiplied by Q, is can represented by the straight line equation. And then when you see on the third one, total revenue and total cost, right? When you see on the right hand side of the picture number 3, when total revenue more than the total cost, it means you can get the profit. And another one, when total revenue less than the total cost, you will get loss. And then when you see when the total revenue and the total cost are equal or intersect point right here, it means you can get the break-even price. And the next one, we go to the basic assumption for this technique. The first one is involve only one product. And the second one, everything produced can be sold. The variable cost per unit is the same regardless of the volume. The fixed costs do not change with the volume change. The revenue per unit is the same regardless of the volume, and revenue per unit always exceed the variable cost per unit. The next one, we show you the example how to calculate on the cost volume analysis. For this example, the owner of the old-fashioned berry pie, S. Simon, is contemplating adding the new line of the pie, which will require leasing the new equipment for the monthly payment $6,000 US. The variable cost would be $2 per pie, and the pie would retail $7 each, right? On the first question, they want to know how much pie must be sold in order to get the break-even point. They want to calculate the break-even point for the problem A. When you see for the problem A, in this problem, they tell you the fixed cost, right? The fixed cost for leasing the new equipment is $6,000 US, and the variable cost per pie $2, and revenues or retail price is $7 per pie. For the problem A, they want to get the break-even point, right? Q break-even point equal to fixed cost divided by R minus 3, right? You know everything, just substitute to equation 6,000 divided by 7 minus 2, or equivalent to 1,200 piece of pie per month. It's just like the break-even point for problem A. And the second question, let me go back to the previous slide. On second question, they want to know what would the profit or loss be if 1,000 pie are made and sold, right? You just really know the break-even point is 1,200, right? It means these companies can get lost, right? Because Q is just only 1,000, right? How much for the loss? For the equation, P equal to Q multiplied by R minus V minus fixed cost, right? You just really know Q 1,000, you know R and V already $7 and $2, right? Minus fixed cost 6,000 means this company can get lost $1,000. And problem C, how much price must be sold to realize the profit target $4,000? For the problem C, they give the profit target 4,000 and they want to calculate the volume of the pie sold or the Q, right? From the equation, right, you can get Q equal to 4,000 plus fixed cost divided by retail price minus the variable price is equal to 2,000 price. Mean if the company want to get the profit 4,000, they must make and sell 2,000 piece of pie. And the last problem, they want to know if 2,000 pie can be sold and profit target is 5,000, what price should be charged per pie? They want to know the new revenue price, right? For the profit equation, profit equal to Q multiplied by R minus V minus fixed cost. Profit is 5,000, Q equal to 2,000, right? They want to know the new value of the R, right? They just the variable cost is 2 minus fixed cost, and then after you solve, you get the new retail price is equal to $7.15.